All right, welcome back everyone. This is the Calculus 2. So in this video, we are going to talk about 1.3, the fundamental theorem of calculus. So in the previous two sections, we looked at the definite integral and its relationship to the area under the curve of a function. So we talk about the meaning of the integral, where it came from. So we talk about the Riemann sum and coupled theorem. So in this section 1.3, we're going to look at some more powerful and useful techniques for evaluating definite integrals. So we're going to see a bunch of formulas that I've been briefly show you in the last video. So before we're going to get into this, I'm going to examine a very important theorem, which is the mean value theorem for integral, and then this is very important to discuss fundamental theorem of calculus we're going to talk about in 1.3. So here, we're going to talk about those ideas, and let's talk about mean value theorem. This is one of the theorem that I want to elaborate today. So last session, we talked about how to find out the average value of a function. So it's very similar from that idea. So in mean value theorem, let's say you have some function. I want to find out the mean of that function. So the idea is very similar from the average formula. So if you guys remember, to find out the average value, we are going to take the integral. So there's a given function f of x from a to b, and then simply you are multiplying 1 over b minus a. So mean value theorem and average value theorem, they're pretty similar. They're very, very, very corresponding to each other. One thing is, so let me write it. So now I have f of c. I want to find out the particular value of c that gives you the average of the function. So that's what that means. 1 over b minus a, so a to b, f of x dx. So what I'm going to do mathematically, let me multiply b minus a on both of sides. So what happened? The b minus a, top and bottom, they're going to cancel. So b minus a, f of c, a to b integral, f of x dx. This is also corresponding to each other. So therefore, so mean value theorem, you can use either, average value formula, or as I modified, multiply b minus a on both the sides. So those are two formula are going to give you how to where the mean value of the function. So it sounds like a little bit abstract. I'm going to give you guys example. So maybe by looking at this example, you might have a clear idea what we are going to do. So let's take a look at the example one. So I have function. So what's going on here? So when you look at so let me change the color. So let me look at the integral. That means it helps us to find out the area from 0 to 3 with the particular function, in this context, x to the second power. And then when they measure that area, it's 9. So let me draw that image. So parabola, x to the second is a beautifully upward shape, right? And then from 0 to 3, under the curve, they're saying that this area is 9. I'm literally interpreting what this integral symbol and 9 means. So now, in this information, there is a c, such a c, right, that gives you the average value of that function x to the second power. I want to find out the particular c. So this is the x-axis. So between 0 to 3, there is a particular number c that gives you the average value of that function. So that's what they're asking you to find out the average value. So you can use either average value formula or mean value theorem. So they're pretty much talking about the same thing. So let's utilize the formula that we have. So I do have f average is f of c equal to 1 over b minus a to b, f of x dx. So let me plugging in all the given information. So this is the, given from 0 to 3. So b is 3, a is 0. So we already have it from here. So 1 over 3 minus 0 and I have a 0 to 3. The function is x to the second dx. And then we need to find out a particular c that gives you the average number. But and then we already know that this is 9. This is already given. So 1 over 3, this is a given as 9. So we multiplied it. It is 3. So what does it mean? We don't know what the c. When you're plugging in c, the average value will be 3. Okay, that's what that means. So we want to find out this average point. So we don't know what the x, but we found out it is 3. This is a relationship. This is average value. So how am I going to find out c? So now we're going to use the given function. So since f of x equal to x to the second, if I'm plugging in c, it is going to be c to the second. We know that f of c, c to the second is equal to 3, because that's the relationship input and output. So if you're plugging in c, they say output is a 3. And then f of c is a c to the second. So we are going to solve this equation. C to the second equal to 3. So c is going to be plus minus 3. So plus of radical 3 minus radical 3. So we need to make sure negative is not going to be part of that, because your interval is going to be 0 to 3. So basically your c is going to be radical 3. So my conclusion is c equal to radical 3. This is in the interval 0 to 3. And we verified mean value theorem. So this particular c, when c equal to positive radical 3, we have the average value. That's the answer. So just I want to briefly talk about this mean value theorem, which is really relevant to the average value theorem. So we are looking for a particular c that gives you the average value. So once you have all the information plugging in and find out that particular c. So this is just one example. Okay. So I'm going to briefly talk about it. And then I want to talk about the main idea, fundamental theorem of calculus in 1.3. Okay. So let me go to the next slide slowly and surely. Here we go. All right, fundamental theorem of calculus, what that is and why it is important. So if you guys remember in calculus 1, it is all about derivative. It is all about differentiation. Calculus 2, it is all about integral. So fundamental theorem of calculus, this is a really, really popular theorem. They're emphasizing on the relationship. There gotta be a relationship between differentiation and integral. There might be some relationship, integral. And as you know, integral has another second name, antiderivative or antidifferentiation. So in somehow taking differentiation, taking derivative, taking integral, they have some relationship. So what is the relationship? That's what we are going to discover. So the definition is here, but I want to give you guys more visualized concept. So if you remember the definition of the integral, we do have a function, right? So let's say I have f of x, and let's say I want to find out the area between a and b under that function f of x. So let's say that is a capital letter f of x. So the capital letter f of x, this is area, is equal to, by taking the integral, because integral help us to find out the area between a and b, and you are taking the integral, the given function f of x, and then you can find out the area. So this f of x is a function, and letter capital F of x is area. So in other words, this integral symbol, by taking integral, you can find out the area. By taking integral, or antiderivative, you can find out the area. So f of x, the little f of x, by taking the integral, you can go to capital letter f of x. But in other words, if you do the backward, what is a backward of integral? That's derivative. If you're taking just derivative, so we already have area. If you take the derivative, right, that's a symbol, you can find out the function that is given. So that's the relationship. So it's like by taking integral, you can find out the area. By taking derivative, you can find out what the original function was. So that's the relationship, and that's what the fundamental theorem is talking about. So from here, the derivative is a prime that is equal little letter f of x. So that relationship is true. So one more time, it's not really confusing. By taking integral, you can find out the area. By taking derivative, you can find out what the function was. Okay, so that's this fundamental theorem is showing you the relationship, derivative and integral. They're really, really related to each other between area and function. So therefore, fundamental theorem, they're showing you the relationship, capital letter f of x. If you take the derivative, you can find out the function, what the function was before. Okay, so this is a fundamental theorem 1. So now 1.3, they also have a fundamental theorem of calculus part 2. So part 2 is more useful because it actually helps us to find out the actual number. So let's take a look at the fundamental theorem of calculus. So part 1 is an introduction, what the idea, what the relationship between derivative and integral. And now we're gonna really calculate it, okay? So let me go to there slowly. So take a look at it slowly. And then calculus, fundamental theorem of calculus part 2. So this is more and more popular. So the part 2 actually help us or show us how to calculate the area between the interval under the curve. So if I just compare, fundamental theorem part 1 only show you the relationship between derivative and integral. So if you take the integral, you can find out the area. If you take the derivative, you can find out what the function was before. So that's a relationship. So part 1 is showing you just simple idea. There's a relationship between derivative and integral. And part 2 exactly show you how to calculate the area between the interval under the curve. So that's actually what we're gonna do. So the idea is this. Let's say we have the same thing. I wanna find out the area between A and B, okay? Mathematically, this is the same. Let's say you have same function, okay? And then this is the B. So this is entire area from 0 to B, f of x. If you subtract, here is A, right? From 0 to A, if you subtract B area from 0 to B area minus 0 to A area, if you subtract them, what happened? You're gonna find out the between area A to B. So this is the fundamental theorem of calculus part 2. So whenever we are going to take the integral, we always gonna subtract the larger area minus the small area. You will find out the between area. Does it make sense? So therefore, this relationship is true. The capital, this is the area. This is the area from 0 to B. And then if you subtract the capital letter A area, 0 to A, you're gonna find out the area actually we are looking for between A and B. So remember, Always a large area minus a smaller area gonna give you the between area. Okay, so that's a fundamental theorem part 2. Now I'm gonna do all the calculation finally. Okay, so hold up there. Let's take a look at the example. So are you guys ready now? So this is all the background of taking integral. So let's really take the integral. Okay, example 3. So now we know what's this meaning. So we are looking for, so integral help us to find out the area. So we are looking for the area of the function 2x minus 1 between -1 and 0. That's what they mean, isn't it? But we need to calculate, we need to take the integral. So these are all the integral techniques. So first of all, if you have 2x, we can separate it. We have a two term, 2x and 1. So I'm going to separate it. -1 and 0, 2x dx minus, I'm separating those two terms into one each term. So -1, 0, 1 dx. Are you okay with that? Just literally I'm separating. Now we are going to take the integral. So this one, always you can bring constant to the front. So that means -1 to 0 x dx, and then -1, 1 dx, correct? And now you need to take the integral. This is the integral part. So let me do, this is the integral part. This is the integral part. So what happened? If you have any variable, so we are taking the integral with respect to x. So look at this. This is the rule. You have invisible 1, correct? And then you are going to adding 1. That's the rule. N plus 1, I'm adding 1 and divided by that exponent 2. Okay, so that's how you finish up the integral. That's it. So this one, you increase one exponent plus 1 and divided by that exponent. And this is from -1 and 0. That's how you write it. And we still have 2 at the beginning. Minus, this is the constant. So we are going increasing one variable. So 1 is going to be x from -1 and 0. So I have a little bit of typo. This one should be 0. Yeah. So that's how we finish up the taking the integral. So now what happened? 2 cancel. X to the second, -1 and 0. We have x, -1 and 0. So what did I say? We are going to subtract large and minus. So always, this is the work. F of 0 minus f of -1. That's what you're going to do. So x 0 to the second minus -1 to the second. This is the first one minus the second one. 0 minus -1. You're plugging in 0 into x. You're plugging in -1 into x. So this is a 0. This is 1, -1. This is a positive 1. The answer is -2. So that's the area from -1 to 0 of this particular functions under the curve. Okay, so keep in mind, just I want to make sure why this is going to be 1. When you take the derivative of x, it is 1. Now we are taking the integral. So integral 1 dx, go back to the x. So they're back and forth, right? So that's why 1 become x. When you take the integral, when you take the derivative, you will get 1. When you take the derivative of x, it's going to be 1. So that's number 1 question. So I'm going to show you that example. Are you guys okay? So it should be fine. So I'm going to keep on going. Example 2 right there. So let me write it. So same thing, I'm going to, you can directly take the integral, but let me separate it. So that means 3x a second dx, 1, 2, 1 dx. So now 3, I can bring it to the front. And then we know that what happened? Taking the integral with 1, go back to x. So one more time, derivative, taking derivative x is a 1. Integral 1, you go back to x. Okay, so this one is going to be x from 1 to 2. All right, so now we are going to take the integral here. We are going, 3 is here, x to the second. You are going to adding 1 and divided by that exponent 3. And then minus, what happened? X 1, 2. They're gonna be canceled. So I forgot here 1 and 2. So we have x to the third, 1 to 2, x 1 to 2. So again, subtract 2 to the third minus 1 to the third. This is the first term. And 2 minus 1. So therefore, 8 minus 1, 1. 7 minus 1. The answer should be 6. That's the area. Does it make sense? So you can do this work. That's how you're taking the integral. So literally, I'm using the second part 2 theorem because here's a large area minus a smaller area. That's what we are doing. So this is f of 2 minus f of 1 we're doing. Okay. So does it make sense? Hopefully, so far so good. All right, so let's take a look at one more example. I'm gonna do here. We have a 1 to 9. We are looking for the area under the radical x. Radical x. So first of all, many people forgot what is a radical means. That's a half exponent. So I can modify this 1 to 9. Half exponent. That's what the radical dx. So do the same thing. Now you're gonna take the integral. So at the end, we're gonna take the radical capital 9 minus capital 1. That's what we're going to do. But let's simplify. Adding 1, you plus 1, and you divide it by 1 over 2 plus 1 is a 3 over 2. And then 1 to 9. That's, you can do that. And then this is ugly fraction. I can flip over by flipping. So 2 over 3, x to the 3 over 2 from 1 to 9. All right, so now we're gonna do the capital letter 9 minus capital letter f of 1. So 2 over 3, 9 to the 3 over 2, 2 over 3, 1 to the 3 over 2. So we're gonna subtract. I'm plugging in 9 and 1 into x, and we are subtract to each other. So this is a capital letter of 9. This is a capital letter of 1, correct? So 2 over 3. 9 is a 3 to the second, and we have a 3 over 2. 2 over 3, 1 to the whatever exponent is always 1. So then these top 2, bottom 2 gonna cancel. So we have a 2 over 3, 3 to the third, 2 over 3. So again, this is going to be 27. And then you can multiply 2. 27 times 2, 54 over 3 minus 2 over 3. The answer is a 50 over 3. That's the answer for number 3. So I'm showing you all the steps how to take the integral. So far, I'm using only one, formula. When you're taking the integral, increasing one of the exponent and divided by that total exponent. Okay. So far, so good. I hope everybody's doing awesome. Those who are watching this video. All right. I hope things going well. All right. Sounds okie dokie. All right. So we're going to keep practicing it. Okay. Don't worry. We're going to get through. Let's take a look at more examples. So this video, we are going to practice how to take the integral. That's important. So let me go down slowly. So at the end, you're going to learn how to use all this function. So depending on the function, if you have x to the n, if you have a fraction, if you have a trigonometric function, these are all the outcome of taking integral, right? Once you take the integral, so far we are using the first one because it's the basic, this is a basic one. But now I have a sine theta. If you take the integral of sine, it is going to be negative cosine. So same thing. If you remember, d over dx of cosine x is a negative sine x. So the same thing, it's a back and forth. That's the relationship between differentiation and integral. So we're gonna do that work anyway. So first of all, we are looking for the area. So sine function, it looks like this. Every 2 pi, they have the same pattern. And this is a pi, this is a 2 pi, and this is a pi over 2. Pi over 4 will be here. So they're looking for the area. 1 is gonna be around here. So we are looking for the area right there, right, of the sine function. So let's take the integral. What is a sine? Take the integral of sine function, negative cosine. So it's going to be negative cosine. There's no n, just cosine theta from pi over 4 to 1. This means you're going to subtract 1. You're going to subtract from pi over 4. So subtract minus cosine 1, right? Minus, because that's a theta, minus cosine pi over 4. Beautiful. So if I change it, minus cosine 1 plus cosine pi over 4. So here, how to calculate this question? So you're going to go to decimal. So let me go to decimal here. So if you want to calculate some complicated trigonometric function, type it. So we do have negative cosine, what was it? Cosine 1. And then we are adding cosine pi over 4. So they're going to calculate it for you, which is approximately 0.167. So that's your answer. So approximately 0.167. That's the area right there. Okay, so this table of the integral help us a lot how to take the integral depending on the function. The function is going to be changing. We never know what kind of function you're going to take the integral or when you're going to take the differentiation. Depending on the function, we have a different rules you need to follow. Okay, I'm not going to emphasize on memorizing this. You don't need to memorize. This is going to be given. So especially if you go to the Canvas, so let me go to Canvas. So my internet might be a little bit slower, but if you go to Calculus 2, right? So let me show you Calculus 2. Okay, please come up the internet. So I have all the module. So if you go to Calculus 2, our module. So if you click module, this is where you're gonna find out the reading textbook. So here, table of integral, table of derivative. So when you learn Calculus 1, you guys been utilizing this old table of the derivative. So when you take the constant of the derivative, it's 0, product rule, quotient rule, things like that. Same thing is happening, table of integral. So depending on the function, and then when you're taking the integral, you have already the answer. So you just use those formula, but you should know how to calculate it. So that's what we're going to learn in Calculus 2. Okay, so I'm just going to briefly show you. So anyway, I already, I have put some important, integral information so you can utilize it. So that's how we're going to do it. It's getting better and better, hopefully. So we're going to do a couple more examples. So we're going to conquer, calculating all the integral part. So let's take example 5. All right, so I do what is going on. So we have a function 6x a second plus 9x minus 4 times e to the x. I'm looking for the area from 0 to 1. So step by step, let's separate it. So that means 0 to 1, 6x to the second dx plus 0 to 1, 9x dx minus 0 to 1 for e to the x dx. Are you okay? So whenever you see the number 694, we can bring it to the front. So that means 6, 0 to 1, x second dx, 9, 0 to 1, x dx, minus 4, 0 to 1, e to the x, and dx. Are you following? So this is all the constant, and now we're gonna take the integral right there. So the first one is easy rule, the basic rule. We're gonna increase x to the second. You're adding 1 and divided by the total exponent 3. And we had a 6 at the beginning from 0 to 1. Are you following? That's how you are utilizing the first rule plus 9 there. And I had a x to the invisible 1. Now you're adding plus 1 and divided by that total exponent 2. And we have from 0 to 1. 4, how do I take the integral e to the x? Look at that right there. So if you take derivative, e to the x is always e to the x. Same thing, you're taking the integral e to the x is the same as e to the x. So it's going to be same, e to the x, 0 to 1. Dun, 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 dun. We good? So let me change this one with the pink color. So e to the x is same. Beautiful. Now, I'm going to minimize it a little bit. Now we're going to do what? Subtract from larger to smaller area everywhere. So when you're doing that, so first of all, you can actually combine all the information. So let me simplify. 2x to the third, and this one, 9 over 2x to the second, 4e to the x, and entire from 0 to 1. That's the same thing, because we just break them into small, and now you can combine back. So that's what it is. So what does it mean? This is a capital 1 minus capital 0. So you can now, so this is a condensed one. I combine everything because, 0 to 1, that's kind of like a common factor. So now what? You're going to substitute 1 everywhere. 1 to the third, 9 over 2, 1 to the second, 4e to the 1. This is the capital letter of 1 minus every 0. So 2, 0 to the third. Actually, that's going to be all 0 because you multiply. But let me continue. Minus 4, e to the 0. So this is capital letter of f of 0. So that's going better and better. So let me a little bit smaller. So what happened? This is 2 times 1 to the third is 2. This is 9 over 2 minus 4e, correct? Minus, this is going to be 0, multiply 0. But guys, e to the 0 is always 1. So therefore, what happened? 4 minus 4 times e to the 0 is 1. So therefore, 2 plus 9 over 2 minus 4e. And then what happened? Minus, oh, actually, I forgot the negative here. My bad. So we have a negative 4. E to the 0 is 1. So double negative plus 4. So at this moment, you can combining all the number. 2 plus 4, 6 plus 9 over 2 minus 4e. 6, it's the same as a 12 over 2 plus 9 over 2 minus 4e. So you can adding them. So that is going to be 21 over 2 minus 4e. That's the answer. Woo, we got it. We got this. Okay, so that's how you're taking the integral. Okay, so far so good. I hope you're getting a better confidence of taking integral. You don't need to scare off anything. This, tips are going to be given from your textbook. So we literally utilize it, but you need to know which one you have to use it. So check the structure of the function. Okay. All right. So if you guys got this one, I love to see you guys a thumbs up. But anyway, you guys should be doing fine. So let's do just 2 more examples. I'm going to keep going. Next one. Example 6. Okay, so now you guys maybe pause this video and you can try first and check the answer with me. You can do that, but I'm going to continue. Okay, so here at the end, you're going to subtract capital letter 1, 0, and then I'm going to separate it. 4x to the second dx, 0 to 1 x dx. So 4 gonna be to the front, 0, 1 x to second dx. And this one, you can take the integral, but let me just write it one more time. So actually, I'm gonna bring this one here. How about that? right? So that's what I rewrite it. So that's what the meaning. Now we're gonna take the integral for x to the second what? Plus 1 divided by that exponent from 0 to 1. And then minus x invisible 1 plus 1 divided by 2, because 1 plus 1 is a 2. And then from 0 to 1. So we got it. What happened? 4 over 3, x to the third, 0 to 1. 1 over 2, x to the second, 0 to 1. So therefore, now you're going to do f capital 1 minus 0. So 4 over 3, 1 to the third, 4 over 3, 0 to the third. So this one minus 1 over 2, 1 to the second, 1 over 2, 0 to the second. So this one, 4 over 3, that's a 0. Minus 1 over 2, that's a 0. So therefore, 4 over 3 minus 1 over 2. You can find out the common denominator. 8 over, I multiply 2, top and bottom. 3 over 6, the answer should be 5 over 6. There we go. We got this. So I'm going to hold up here. Are you happy? Yes, yes, yes. All right, so let's take a look at the next question. So far I've been utilizing only the first basic integral. So this is, I'm going to rewrite it. 1 to 4 radical x dx. Actually, we did this one, very similar one, but let me try it again. Half exponent means what? The radical means a half exponent. So now you can take the integral. X 1 over 2 plus 1 divided by that summation, 3 over 2. Yeah, from 1 to 4. That's it. So that I'm going to rewrite it. You can flip over, you can bring it to the numerator. So 2 over 3, x to the 3 over 2, 1 to 4. So now we are doing capital 4 minus 1. So what happened? 2 over 3, 4 to the 3 over 2 minus 2 over 3, 1 to the 3 over 2. Good job. So 2 over 3, 4 is a 2 to the second. And then what happened? 1 to the whatever exponent is always 1. So they're going to be cancel. Top 2, bottom 2 cancel. So therefore, 2 over 3, 2 to the third minus 2 over 3. So finally, it's going to be 2 over 3 times 8. So it means 16 over 3 minus 2 over 3. Gotcha. 14 over 3 will be the area we are looking for. Does it make sense? So now we can do a little bit faster because you know what is going on. Okay. So hang in there. Last two more questions. A little challenging one. Okay. So if you got this one, I love to see your thumbs up. I know you might watching this video right now, but I hope, right, you're doing fine. All right, so finally, last two more example. Here we go. Example 7. So this is, whoa, Professor Ben, what is that? Ooh, this is like a little bit complicated function. So you have to use your prior knowledge. Do you remember? A little bit of note. In your pre-calculus, if you have x minus 2 over 4, you used to draw like separated by creating the heart. So that means x over 4 minus 2 over 4, right? So we can utilize this one into that function, complicated function. So what does it mean? You can separate it one fraction and second fraction. So let me rewrite it. This means 1 to 9 x over radical x minus 1 over radical x. I just separated, right? Therefore, it is going to be x over radical x dx minus 1 over radical x dx. That's what we are going to do. Just step by step, nothing is complicated. It looks complicated, but it's going to be better We know each meaning. The radical means half exponent. So x over x to the half exponent dx. And then it is 1 over x to the half exponent dx. And then long time ago, another your second prior knowledge, exponent the rule. If you have x to the a, x to the b, do you remember? If you have the same base, you can subtract the exponent to each other. So we're gonna do that work. Here is invisible one, isn't it? So what happened? You can rewrite it. This means x to the 1 minus 1 over 2. So highlight it, highlight it, highlight it. This means x to the 1 minus 1 over 2. Gotcha. And then now, what is this one? Do you also remember another prior knowledge? Note, if you have a negative exponent, you can flip and change it to positive. So x to the, 1 over 2, this is in the bottom. So this means, just remember, please. Oh, sorry. So this one, I'm going to change this one. This means 1 to 9, x to the negative 1 over 2. X to the negative 1 over 2. That's the same as 1 over x to the 1 over 2 because of this relationship. Yes. So in other words, if you have x to the negative 2, it is 1 over x to the positive 2. So we learned the reciprocal. So due to that reason, we can continue here, 1 to 9. So now it is 1 to 9, x to the negative 1 minus 1 over 2 is a half exponent. And then we are going to subtract, right? X to the negative 1 over 2 dx. All right, let's take the integral finally. So we're going to use the first rule. So that means I'm going to just make a little bit smaller. So here, x, this is going to be x to the 1 over 2 plus 1 divided by 3 over 2 from 1 to 9 minus x negative 1 over 2 plus 1 over 1 over 2, 1 to 9. Are we okay? Now I'm going to move this one. I'm going to flip. So if you do that work, 2 over 3, x to the 3 over 2, 1 to 9, and positive 2, x to the positive 1 over 2, 1 to 9. Yes? So now we're going to do all the f9 minus 1. So 2 over 3, 9 to the 3 over 2 minus 1 to the 3 over 2 minus 2, 9, 1 over 2 minus 2 times 1 to the 1 over 2. So that's your last calculation. So 2 over 3, this is a 3 to the second. We know 2 will be canceled, just to 1, minus 2 times 3 to the second, 1 over 2. This is 2 times 1. So cancel 2 over 3, 3 to the third, 2 over 3, minus, cancel 2 times 3, minus 2. So this is going to be 27. So if I multiply 54 over 3 minus 2 over 3 minus 6 minus 4. So 54, what is it? 54 over 3 minus 4. So that is going to be 54 over 3 minus 12 over 3, because I'm making a common denominator. So one more time, this is a 27 times 2, which is a 54 over 2 minus 2. Uh-oh, I have a mistake. This one should be 52, right? 54 minus 2, 2, and 4. This is a 2. So the answer, 40 over 3. Okay, that's it. That's it. That's it. Nothing is special. We got this. Are you guys okay with that? So that was the, this question, and I'm going to show you all the work. Okay. So if you have a complicated fraction or function, you have to simplify, then you're going to simplify as much as you can, then take the integral. So that's the work, how you can take the integral with the complicated fraction. Okay. All right, that should be great so far. I'm going to do finally the last question. I promised you the last one here, which is this. So let me bring that all the way down. So we do have -2, 3 absolute value function. So in this time, we are dealing with the absolute value. So hold up. Do you remember the meaning of the absolute value? So the absolute value is the distance between 0 to whatever the particular number. So if I look at the absolute value, you have to think about it. So the absolute value, right? You have a 2, x is a positive. It's going to be x. But if x is a negative, right? It's going to be the positive. You have a 2 different domain. That's the absolute value means. So for example, if I have a 3, right? Let's say I have absolute value x equal to 3. X can be positive 3, x can be negative 3, because absolute value 3 is always a positive. Absolute value -3, although you have negative, it's a positive. Because that means the distance from 0 to 3 and +3 and -3, the distance is always a positive. So even though you're going to the left direction, the right direction, the distance is a positive. So absolute value indicate that the outcome is always a positive. So just keep in mind a little bit of background of the absolute value. So based on that knowledge, we are taking the integral, right? With the integral with the absolute value function. So we have 2 things going on. So here, this is the absolute value graph. So in this case, they're looking for from -2 to 3. So one go to negative direction, another one is a positive direction. So what you need to do, this is what you need to set it up. It means you have 2 different domain. One is from -2 to 0. And then this is a negative direction. So it is going to be -x dx. I'm going to bring here. Plus, we have a 0 to 3. And then this is always positive x. So this absolute value, okay, I'm going to highlight it. This absolute value indicates that you have 2 different domain. One is a -2 to 0, another one is 0 to 3. And then this one should be -x, this one should be positive x, because we have 2 different domain. One is a left, one is another. So simply we are taking the integral of this 2 integral. So therefore, I'm going to bring here. So we're going to take the integral. So that means I'm going to bring -2 to 0 x dx plus 0, 3 x dx. So now that means you're taking 1 plus 1 divided by 2, -2 to 0, x1 plus 1 over 2 from 0 to 3. So if I calculate it, this -1 over 2, x to the second, -2 to 0, 1 over 2, x to the second from 0 to 3. So finally, we're going to calculate. This means you're going to substitute 0 and minus -1 over 2, -2 to the second, correct? I'm going to just minimize it a little bit. Plus 1 over 2, 3 to the second, and 1 over 2, 0 to the second. Okay, we get. So this is going to be 0. That is going to be 0 because you have a 0. So this is going to be negative, change to positive. 1 over 2, -2 to the 2 is 4, plus 1 over 2 times 9. So cancel to plus 9 over 2. We have 4 over 2 plus 9 over 2, 13 over 2 will be the answer. That's it. We got it. Okay. So the last question, you need to think about it, the characteristic of the absolute value function. So the absolute value means you have two different domain. One is a left side, another one is a right side. You have two different domains. So therefore absolute value, one is a negative x from -2 to 0. Another one is a positive x from 0 to 3. And then you're taking the integral of those two terms. Okay. So that's all about 1.3. So we practice many, integral questions. So now you can complete all the 1.3 quizzes, and there are definitely embedded video you can watch and practice more if you need. If you have any question, you can participate in the discussion chapter 1. That's the place where you are engaging with other people, working together. If you have question, posted it. I might be able to answer, and other students might be answered. You are working together to the discussion board, okay? So take a look at it and feel free to email me if you have any question. I will see you guys in the next video. Thank you, everyone. Talk to you soon. Bye-bye.